Have fun with magnets. People have known about magnets for thousands of years. They have been using them also as compass to know the directions since long ago. But we have learned how the magnetism works in the last century with more advancement in the field of minute structure of materials. Scientists then described that the magnetism is the strange, invisible force of attraction between certain materials. Since then, the magnets have occupied almost all the spheres of modern-day lifestyle. The electronic goods are quite common objects where the use of magnets is indispensable. Discovery of magnets. It is difficult to estimate the exact time of the discovery of magnets. The word magnet came into existence more than 500 years ago in Greece. Long ago in the town of Magnesia, a shepherd named Magnus accidentally touched the iron sole of his wooden stick to a blackish rock. He was terrified as it got stuck when trying to hold its stick. It seemed as if the stick was being attracted by the rock. This rock was the first known natural magnet and was given the name magnetite on the name of the shepherd. Thus the magnet was first discovered in Magnesia. The substance magnetite has special properties to attract iron and to always rest in north-south direction if suspended freely. Magnetic and non-magnetic substances. A material that attracts certain metals such as iron, nickel, cobalt is said to be a magnet. The property of attracting substances by the magnet is known as magnetism. The materials that are attracted by a magnet are called magnetic substances. Examples of magnetic substances include iron, cobalt, nickel, steel, etc. The materials that are not attracted by magnets are called non-magnetic substances. Examples of non-magnetic substances include rubber, plastic, feather, paper, leather, etc. Natural and artificial magnets. There are two types of magnets, that is, natural magnets and artificial magnets. Natural magnets are available in nature. For example, magnetite, hematite, and many other iron-containing rocks. Artificial magnets are man-made magnets. They are not available in nature. They are made of metals like iron, nickel, and cobalt. The shapes of artificial magnet may be of the different types: bar magnet, horseshoe magnet, cylindrical magnet, rod magnet, circular magnet. Temporary and permanent magnets. Magnets may be made of pure iron or soft iron or steel. Steel is made by adding a small amount of carbon to pure iron. Soft iron can be magnetized easily but cannot retain its magnetic property for a longer period. Therefore, they are not used to make permanent magnets. They are used to make electromagnets only. Steel is used to make permanent magnets as it can retain its magnetism for a longer period. The alloy made of aluminium, cobalt, nickel and iron is used to make strongest magnets. Some materials can be easily magnetized or turned into magnets are called ferromagnetic. These materials can be described as soft or hard. The soft ferromagnetic materials such as iron quickly lose its magnetic properties. Magnets made from these materials are called temporary magnets. Hard ferromagnetic materials such as steel retain its magnetic properties for a longer time. They are used to make permanent magnets. Magnetic field. Suppose you put a bar magnet or a horseshoe magnet onto a table and place an iron nail nearby. The magnet slowly moves towards the nail. But there comes a point when the nail jumps across and sticks to the magnet. This is because the magnets have an invisible magnetic field that extends all around them. A magnetic field is an area in a magnet in which its magnetic force is strongest. If iron fillings are sprinkled around a magnet, they gather together where the magnetic field is strongest. Two identical poles push each other away, so iron filings curve outwards. Two different poles attract, so the iron filings run straight between them. Methods of making magnets. If you strike a needle about 50 times with a magnet, it will become magnetic. Striking the needle in the same direction turns its atoms to force in the same direction. Various methods are available for making magnets. for example single touch and double touch methods, using electric current, etc. Nowadays, all magnets are made with the help of electric current. Single touch method. In single touch method, when we strike an iron bar with north pole of the magnet, the iron bar becomes north pole. The other end of the iron bar becomes south pole. The poles can be reversed by striking with south pole of the magnet. This is known as single touch method. Double touch method. Two magnets are used to strike the iron bar in double touch method. In this case, north pole of one magnet and south pole of another magnet is used. The iron bar is struck from the middle of it. This method is used to make strong magnets. Properties of magnets. A magnet shows some basic properties. Demagnetization on heating, beating, and dropping. Each molecule in magnet behaves like a small magnet. When a magnet is heated or hammered for some time, the alignment of the molecules is disturbed and the magnet loses its magnetic property and it becomes demagnetized. The process of losing magnetic property by magnets is called demagnetization. Poles of a magnet cannot be separated. The cutting of a magnet into pieces cannot separate its poles. In the cut pieces of magnets, each piece has two separate poles, that is, north pole and south pole. Even in the minute piece of magnet, both poles exist and act independently. Thus, one pole cannot be separated from each other. Magnetic strength is more at poles. The magnetic strength on the surface of the magnets is not uniformly distributed. It is always at both ends of the magnet. The regions of a magnet where the magnetic force is strongest are called magnetic poles. Every magnet has two poles. Property of repulsion of magnets. The unlike poles, north and south of a magnet, are attracted to each other, whereas like poles, north-north and south-south, show repulsion. A magnet always rests at north-south direction. On suspending a magnet freely, the end of the magnet that always directs towards north is called north pole, and the end which directs towards the south is called south pole. Thus, magnets show directional property. Earth's magnetism. The Earth behaves as there is a powerful magnet within it. Electric current flowing within the Earth's magnetism is called geomagnetism. Sir William Gilbert in 1600 first time suggested that the north pole of the magnet rests towards geographical south and the south pole towards geographic north. We can believe this fact because of the following reasons. When a bar magnet is suspended freely, it always rests in north-south direction. When an iron piece is buried in earth along the north-south of the earth, it becomes a magnet after some time. A magnetic compass needle always points towards north. But when it is placed close to a bar magnet at some points, it becomes free and can rest in any direction. When an iron piece is buried in earth along the north-south of the earth, it becomes a magnet after some time. A magnetic compass needle always points towards north. But when it is placed close to a bar magnet at some points, it becomes free and can rest in any direction. These points are known as neutral points. At these points, magnetic force by the bar magnet is equal and opposite to that of the Earth's magnet. Uses of magnets. Magnets have widespread uses. It would be difficult to run several machines, instruments, household gadgets without magnets. Some common uses of magnets. Magnets are used in telephones, computers, television, refrigerators, toys, electric motors, generators, loudspeakers and microphones, etc. Magnetic compasses are used by sailors and pilots to find the direction. Doctors use magnetic therapy for the cure of certain diseases. The cards like credit, debit, and ATM all have a magnetic strip on one of their sides. This strip contains the necessary information to contact with the particular account. If you find them in toys, blenders, fans, hair dryers, washing machines, motorized toothbrushes, and razors, magnets are used to separate iron scrap from waste dumps. Storing magnets. Magnets tend to lose their properties with the passage of time. Improper storage can also cause the loss of magnetic properties. For this reason, magnetic keepers are used to increase the longevity of magnets. Magnets should be kept in pairs with their unlike poles on the same side. They must be separated by a piece of wood, while two pieces of soft iron should be placed across their ends. For horseshoe magnet, one should keep a piece of iron across the